Hello, this is Professor Eric Roldan. I am here to do a quick review of Chapter 4, Systems of Numeration for Explorations in Math. Now, this is assuming that you have already completed your homework, which includes 4.1, 4.3, 4.4, and 4.5. So once you've completed your homework, then you can watch this video, and also in this video I'm going to share some tips. For example, test questions can come from a variety of sources, including your notes. Basically, that's the workbook. It can come from your My Math Lab, homework as well. Also, you can use optional quizzes for extra practice problems. Okay, so this is page 5 in your workbook. So let's go ahead and get started doing a couple of these. We might have done some of these in class, but most of them we have not. So let's start with the first objective that you need to remember that's going to be on the test is to write the Egyptian numeral as a Hindu Arabic numeral. So you're going to have the chart on the test. So that's something you won't have to memorize. Just know how to use it. So we have 3 astonished persons there. So that will be 1,000,000 each. So this is going to be 3,000,000. We have 3 tadpoles. So that's going to be 300,000. That's 100,000 each. We have 2 pointy fingers. That's going to be 10,000 each, or 20,000. And then we're going to have 5 lotus flowers at 1,000 each. So that's going to be 5,000. Okay, put all that together and you have 3,325,000. Okay, so make sure you know how to translate that way. And then to be able to translate in reverse. So you have, write the numeral as an Egyptian numeral. So we'll do 14, which is 2,301. So I recommend you expand this out. Well, you don't need this 1, just put a 1. Okay, so that's going to give us, we're going to have to use 2 lotus flowers for the 2,000. We need 3 scrolls for the 300, and we need a 1 for, a staff for the 1. All right, so that's Egyptian stuff. Now, Roman numeral translations. Okay. So we have again, this is going to be on the test, the chart. However, there are some various rules that you need to remember. So the first one being that the C we know is worth 100, And there's another 100 right here, the other C. So that you're not allowed to do CXC unless the X is connected to this second C. So these two are together. They are, it's a subtraction problem. So that's actually 100 minus 10. And then this part right here would be 4, which is 5 minus 1. So let me not skip that part. Okay, so this is really 100 plus 90 plus 4, which is 194. Okay. And let's take a look at the next one. We have two M's, and they're 1,000 each, so that's going to be 2,000. D is greater than C, so that's still going to be adding, so that's going to be 500. C would be 100. And then we have X, which is smaller than the L, so that means there's a subtraction right there. And L is 50, so we're going to subtract 10 from that. And then you have 2 right there. So this is really 40. So 2,000. This is going to be 600 right there. And 42. Okay, let me add one more just as a reminder about a few of the rules. And that would be like 99. Okay, where 99, let me tell you what it doesn't equal. So it doesn't equal 100 minus 1. So that will look like this. That's a violation because, violation of the rules because 100 is way too far from 1. It can only be 2 spaces away. Okay, so you cannot subtract 1 from 100. You also cannot try to do 50 and then try to do 40 like this, 49 like that. Okay, so this is a violation, that's a violation of the rules, and so the actual answer would be to do 10, take away 10 from 100, so that would be XC, so that's the 90, and then do a 9 like that. Okay, so that would be 90 plus 9. Okay. Okay, what about if we go backwards? So here's another objective. So go backwards and you're going to do, let's go ahead and just split up. So this is going to be 1,000 plus 900 plus 10 plus 4. Once you split it up, now we can start labeling each piece. So 1,000 is M. 900, we're going to do 1,000 minus 100, so that's CM. 10 is just X, and 4 would be 1 minus 5, so that would be, 5 minus 1, so that would be 1V. So we put that together, IV, sorry. Okay, so that takes care of basically Egyptian and Roman numerals. So remember that that these two are additive systems. because notice what we're doing is we're adding, okay, and we're adding, okay, so those are additive systems, okay, versus ours, which is place value. So you will have a question on place value for ours, and that pretty much looks like this. So let's just take the number we just did, number 19, that had 19, 14, and so the directions are going to say write the given number in expanded form or notation. So that means we would do 1,000 plus 900 plus 10 and plus 4. So this is really 1 times 1,000. This is 9 times 100. This is 1 times 10 and 4 times 1. Okay. And it might be this way or it might be this way. Okay, either one is fine. You'll see. Okay, so let's move on. So let's go to 4.3 exercises on page 9. And this is where you're working with other bases and just doing conversions. So convert other bases to base 10. This is where you're going to multiply and add, okay? So this is the procedure that involves multiply and add, okay? So you expand this out. So remember, that means 2 groups of 4. This means 3 ones, okay? 3 extra. And that's because this is the first place value, this is the second place value. So we multiply and add, so we got the 8 plus 3, and that equals 11 base 10. Okay, so in other words, that's 11 items. All right, so we're just going to expand these numerals. So remember, before you expand it out, you can kind of say, hey, this is worth this much. The second spot is worth this much too. And then 4, and then 8, and then 16, and then 32. So that 1 is worth, it's in the 1, 2, 3, 4, 5, 6 spot, so it's worth 32. In base 2, this is worth 16. The zeros we can pretty much skip. One times 4, and this one over here is just our remainder, our extra. So what we're going to have is 32 plus 16 plus 4 plus 1. Add that up and you get 53 base 10, or like 53 items. Okay? Base 12. So we have 1, 12, and then 12 squared is 144. So this A, remember that A equals 10. So this is really 10 times 144. This 9 is actually 9 times 12, and this is 1 times 1. So 1440 plus 108 plus 1. This is 1,449 in our base system. Okay, so make sure you know how to convert other bases to our base system. Then another one would be to go backwards. Convert each of the following to a numeral in the indicated base. So our base system to base 2, for example. So actually let's do 14. So 23, think of that as 23 items, chairs, fingers, whatever you want to call it. Okay? And we're making groups of 3. So base 3, remember, this is groups of 3. So let's go ahead and get the place values of 3. So place values of 3 would be 1, 3. 3 squared is 9. 3 to the third is 27. Whoop, that went too far because I don't have enough. I only have 23 items. I can't make a group of 27. So my answer is just going to have 3 place values in it. Okay, so once you know those place values, that's what you're going to divide. I'm going to divide 9. How many groups of 9 can I make? How many groups of 3 can I make? And how many extra are there? So take our 23 items divided by the first place value to the left, which is 9. So we can make 2 groups of 9. That's 18. Remainder of 5. We have 5 items left. We can make 1 group of 3 out of that with 2 remainder. And then, oops. And we're done. Okay, so our answer would be right there. So 2, 1, 2, base 3. Okay, so let's take a look at base 8, same process, okay? We have 1,908 items. We want to make groups of 8. And so we want to do the place values of 8. So we know it starts with 1, and then 8. 8 squared is 64. 8 to the third power, or just multiply 64 times 8, and you get 512. If you do that again, you're going to get 4,096. That's too big, so we're going to stop there, which means our answer is going to have 1, 2, 3, 4 place values. To get the digits for those place values, we're going to go ahead and divide by each of those. How many groups of 512 can we get? How many groups of 64? How many groups of 8? And how many left over do we have? So 1098. We can do 2 groups. So 2 times 512 would be 10,024. Subtract, we're going to get 74. How many groups of 64 can I get out of those 74 that are left? I can only do one. Leaves me with 10. How many groups of 8 can I get with that 10? Only one. And 2 remainder. So basically the answer is right there. 2, 1, 1, 2, base 8. Okay, now let me do an alternate method for that same question. So let's look at I think I called this in class the video method. So basically you could go down. Okay, so you would say we'll build like a little ladder first, so we can do 1, 8, 64, 512. So we take 1098 divided by 512, and that equals 2 with a remainder of 74. And then 74 divided by that 64 is 1, remainder 10. And then that 10 divided by the 8 is 1, remainder 2. And the 2 divided by the 1 is 2, remainder 0. So another way to get the answer would be right there. Okay. So I'll accept either way, or there's even a third or fourth ways, that's fine. As long as you're showing some calculations and your answer makes sense, actually this is multiple choice, so you're good. Okay, so if you skip on over to page 11, 4.4 computation are the bases. We don't have extra exercises here, but there's plenty of problems. We didn't get to do all of them in class, so I would like to do just these 3 right here. Actually, I'm sorry. Just those 2. This one is not on the test, okay? It's not going to be that high for addition, okay? Okay, so 7 plus 4. So remember, just doing one column at a time. So 7 plus 4, that's 11 in our system. But in base 8, we're making groups of 8. So every time you have 8, you need to make a group. So 11, that's one group of 8. And then 11 minus 8 would be 3. So the numeral would be 1, 3, base 8. So we're going to put a 3 here, carry the 1. And that's going to be 9 items. And that's 1 extra from a group of 8. So that's going to be 1, 1, base 8. Carry the 1. And then that's 13 items in that last column. And that's going to be 1 and 5 extra. Okay, so that's going to be 1, 5, 1, 3 is the final answer. Base 2, 0 plus 0 is 0. 1 plus 1 is 2. So 2 items in base 2, you just completed a group. So that is 1, 0, base 2. So 0, carry the 1. We have it again. And then the last column is 3 items. And that's 1 extra from the group of 2, so that's going to be one group of 2, one extra, so that's going to be 1, 1. Okay, and again, base 16 is a little bit too high for our test. Okay. All right, now we're going to do some subtraction. This is also 4.3. I'm sorry, 4.4. And we're just going to do these three. So we have a base 8, base 2, and a base 12. So number 12 is base 8. And we're going to borrow in groups of 8. And we're going to give 8 to the next number that needs it. Okay, so the 3 needs some help from the 7, so we're going to take that 7 groups. We're going to take one of those groups and give it to this 3. So that is a 8 plus 3 is 11, and that basically came from adding 8 to that 3. Okay, so 11 minus 4. Oops. Would be 7. 6 minus 5 is 1. Okay, now the 1 needs help from this 2, so we're going to take 1 there and add 8 to this 1 to make it 9. And 9 minus 6 is going to be 3. Okay, then we go to base 2. And we need help from this 1 way over here, so he's now 0. And then we're giving 2. Okay, so that's one group of 2, so we're going to give it here, so that's 2. And I'm going to take 1 away from that one, give it to this one here. Okay, so 1 minus 1 is 0. 2 minus 1 is 1. 1 minus 1 is 0. So basically, we're done. Number 15 is base 12. So remember that A equals 10, B equals 11. So 3 minus 10, that's not enough, so we need help from this 9. So we're going to take one group of 12s from there, make it 8. We're going to add 12 to this 3 to make it 15. So we're doing 15 minus A, which is actually 15 minus 10, which is 5. 8 minus 6 is 2, so that's good. We're going to need help from this B. Remember, B is 11. All right? So if this B is 11, we need to take a 1 away from it to make it 10. And we're going to give a group of 12 to this 2 to make it 14. So 14 minus 8 is 6, and 10 minus 4 is also 6. So 6625, base 12. So I also want to do some counting. So this comes from our workbook as well. So just remember, so let's say let's use base 2. That was a weird one. So base 2, so you start counting 1, 1, 0, and then an extra. So 3 items will be 1, 1, and 2 groups of 2 will be 100, or I'm sorry, 1, 0, 0. Then it starts over again. So that, and then we get to basically we just maxed out our 3 place values, so now we need the 4th place value. Okay, so that would be 1, 2, 3, 4, 5, 6, 7, 8. Okay. Let's do base 7. I'm sorry, base 8. That's on the paper. So base 8 is basically you know what, I forgot the 0. The 0 should be here actually. So let me start it with 0. And then you can start counting things. So 1, 2, so we make our first group of 8, and we keep going. Etc. etc. Okay. Base 16. Remember, I don't have enough room, so it's gonna be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we had basically A, B, C, D, E, F. Okay. So those are just like some examples of counting. All right, last of all, we'll do some alternate methods of multiplication, basically historical methods. And so we can do, let's say a 3 by 2. So we'll do this one. And this one here. Okay, so remember, the first thing you do is set up your chart. So divide on the left, multiply by 2 on the right. Then you write down your original numbers. And then you start dividing by 2. So 15 divided by 2 is 7.5. Drop the 0.5. 7 divided by 2 is 3.5. Drop the 0.5. 3 divided by 2 is 1.5. Drop the 0.5. So we just have 3 more rows to fill. So 342 times 2, 684. 684 times 2, 1368. 1368 times 2 is 2,736. And then we got to look for even numbers on the left side. And if you look, these are all odd. So all odd, no evens. That means we don't cross anything out, any rows. So we're going to use all 4 of those. So 342 plus 684 plus 1368 plus 2736, that's all going to equal 5,130. Okay. Now let's do the other one. So 184, 423. So if we cut this 184 in half, we get 92. Cut that in half, we get 46. Cut that in half, 23. Cut that in half. You get a decimal, drop that decimal. Divide this by 2, you get another decimal, drop it off until you get to 1. When you get to 1, you're going to stop. And then you're going to fill out the rest of the right side. So if you double that, you're going to get 846. Oops. And 1692 and 3384, 6768, 13, 536. Okay, so this time we do have some even numbers on the left side. So it's actually starting with the first row. So this is even, this is even, this is even, and this is even right there. So we're going to cross out that row, this one, and this one. Which means we're going to add up these 3 and this one. The final answer is 77,832. Okay, our last section, the lattice method. And so, as you can see, the way this lattice is set up is three digits times 2 digits. So we're going to put the 438 on top. And the 72 on the side, just because the way the lattice was set up. Okay. So 8 times 7 is 56. 7 times 3 is 21. 7 times 4 is 28. 4 times 2 is 8. 3 times 2 is 6. And 8 times 2 is 16. Extend these out. And so this is 6. And these 3 numbers is going to be 13. Carry the 1. So all this right here is 15. Carry the 1. And that's 11. Carry the 1. And this is, of course, just 3. So final answer is right here. 31,536. Okay. What about a 3x3? So now it doesn't matter where I put my numbers because it's the same size. So I can do 369 times 428. And we just multiply. So 9 times 4 is 36. 6 times 4 is 24. 3 times 4 is 12. 9 times 2 is 18. 6 times 2 is 12. 3 times 2 is 6. 9 times 8 is 72. 6 times 8 is 48. And 3 times 8 is 24. So you can quickly fill out your box. Extend out your diagonals. And start adding. So that you bring this 2 down. You add these 3 up. So that's going to be, 16 plus 17. That is going to be 23. He added all these numbers up. Okay, so that's going to be 19. add those numbers up right there. All these right here. That's going to be 17. And then 5. And then bring down the 1. So 15,000. I'm sorry, 157,932. All right, well, guys, that concludes a quick review. It wasn't so quick. It's probably the same amount of a class period. So, like I said, we ran out of time in class. Hopefully, you can watch this video as many times as you want, and can go back over all the different types of questions we did. So, lattice, duplation and mediation, counting, subtraction, adding, converting our numbers to other bases, which involves division and subtraction, converting other bases to our numbers, which involves multiplication and addition. Then expanding numbers in our base system, dealing with additive systems like the Romans, so doing the translation from our numbers to theirs, from their numbers to ours, from our numbers to Egyptian, and from Egyptian to ours. And that's it, guys. So again, study your notes, the workbook that we just kind of went through, some of the exercises, the My Math Lab homework, and of course you can get some extra practice without help on those quizzes, okay? So that's the point of the quizzes, is to try without help. Okay? You're trying to simulate the testing scenario. Okay? No notes, just a calculator, and see how you do. Okay? If you don't do so well on the quizzes, remember they don't count, but I would definitely try to get A's. I'll keep doing them until I get A's. All right, guys. Well, email me anytime. eroldan@scu.edu. All right, guys. Have a great weekend. We'll see you next week. I hope you work hard, and God bless.